Hello, my name is Pratham Modi and today I am going to design inverting and non-inverting amplifier using a simulation tool LTspice. So let's begin. First of all, we need to go to LTspice. We are creating a new schematic. So here is the shortcut method for new schematic. So over here we'll be using OP07 since LM741 is not being used as in workspace in LTspice, so we'll use OP07. So for using OP07, go to components. Over here type OP07, you will get it, OP07. Okay, so let me reduce the size of it. Okay, so this is OP07. Now we need resistors. So here are my resistors. R1 will be my first resistor, RF will be my second resistor. So we need two resistors. So to give sine wave as an input, I need voltage source over here, and to give power supply to this, I need two more power voltage sources. So I'll go to again component, voltage sources. So here will be my first voltage source, second voltage source, and I'll go with third voltage source. So we need to connect all of these first. So for connection, go to wire. There you will get wires over here so that we can easily connect all of them together. This is the first connection. We'll be giving ground supply to the positive input of an OP07 terminal. We need a feedback. We will be giving a feedback. So just make sure that you get this dot over here so that it will be easy to understand that yes, your wires are being connected properly if you are intersecting two wires. I need to give power to this as well, so I need a wire. So here we have two terminals, but we actually need some wire over there to make sure that our supply is properly fed to the voltage sources over there. So, and I need a ground supply, so I need a wire over here as well. So now we'll take a ground. I'll give ground to this. Oh sorry, see, this is where if you don't get it, then there might be an error. So voltage, sorry, ground and ground. So I think the connections are done, but we are designing this inverting amplifier for a gain of say 5. So as the formula says, VO is equals to minus RF by R1. So I have to make this as RF first of all. R2 is also okay, but for better convenience we can use RF. So let me take RF as say 5K. You can change the values of resistors by just clicking, by just right clicking, so that you can get this toolbox, and this will be 1K for a gain of 5. 5 divided by 1 is 5. For a gain of 2, you can take this as 2 and 1. Okay, so now we will be giving input from here, so we'll label it as say V in will be my input label, and this will be my V out. So right click, change its name to VO, and over here we'll be giving, this will be my VCC. So again label so that it's better to understand as well. This is my VCC, this will be my VE. I will change that. So we'll have this 4. I need to change this as VEE, so VEE, and again this will be also changed as VEE. So I think we are done with the simulation. VCC, VCC, VEV. So the power supply has been given, but what power will be given? With power will be say 15 volts, 15. No need to write minus 15 over here because VEE indicates negative supply. So we will be giving sine wave out from V1. So just right click, go to advanced, go to sine. We don't want any offset, so 0 volts. Amplitude, so let's say I will be designing this for an amplitude of say 5 volts. So in LTspice what we need to do is we need to provide half the voltage we need to get. So for 5 volts we will use 2.5 volts, 2.5 volts, and frequency will be 1 kilohertz. So while getting this amplitude, if you want to design it for 4, just give the input over here as 2 volts. so that the output while simulating it will be you will be getting that as 4 volts. So okay, so we have this as okay. Wow, now again simulate, and I don't think anything else is left, so run. It will ask me for stop time. I'll give stop time as 3 milliseconds. You can give it anything, 2 milliseconds, 4 milliseconds, doesn't really matter. Okay, so here we have the output window for where we will be seeing our input and output voltage. You will see a probe, a red probe for V in. Once I connect it to V in, we'll get this as V in and V out. Let me zoom in. Okay, so we had been designing this. So this is, say, let's say, see here you can see Y is equals to 2.57 volts. So this is 2.5 volts, 2.5 volts. So we have designed this for a gain of 5 with 5 volts peak to peak as my input. Now what if if we would like to change this manually, the step input? So go to plot settings, go to manual limits, and type the 1 volts. Let's say 1 volt. Okay, so there you go. This is 2.5, 2.5. 5 volts is what I have given, and this is my inverting amplifier output. So this is it with inverting amplifier. So now for designing non-inverting amplifier, I have made the schematic. So I'll go to open, and I have my non-inverting amplifier design ready with me. Non-inverting amplifier design. So what will be my changes over here? The main changes will be, we will be giving input to the non-inverting side of an op-amp. So in the inverting amplifier, the sine wave input was given to an inverting side of an op-amp, and non-inverting we will be giving it to plus sign. Where you see plus sign will be my input. The designing, I will be designing this for a gain of 2. Let's say 2. So for a gain of 2, since VO is equals to 1 plus RF by R1. So if this is 1, I need to add plus 1 will be added. So this makes my gain as 2 amplifier, 2. Again, so VO, that is my output, is 1 plus RF by R1. So let's take RF by R1. RF by R1 is 1 divided by 1, which will give me output as 1. So what the formula says, VO is equals to 1 plus RF by R1. So 1 plus 1 is equal to 2. So this is how we will be designing this. Again 15 volts, and now I will simulate it and run. This is my input voltage and this is my output voltage. This has been designed for a gain of 2. So here you will see, let me change the plot settings and manual limits. I will give this as 500 millivolts instead of 800. So you can easily identify this is 2 to 4 volts peak to peak. I see what I have given here is 2. As I mentioned earlier, in inverting amplifier, whatever peak to peak voltage you need to give half of it. So over here what I have got is 4 volts peak to peak, and because of which the input which has been provided as an amplitude is 2 volts. So this is the non-inverting amplifier circuit design. And now what if we need saturated output over here? So for saturated output for an inverting amplifier, I have given the input as 16 volts peak to peak. So this is how the saturation will look like. It will be clipped from the inverting side. And for a non-inverting amplifier also, you need to give whatever is your power in DC. Over here if you see, this is 15 volts. You just have to make sure that you give it above 15 volts. That's it. The moment you give it above 15 volts, you will get an clipping kind of an waveforms which you see over here. So this is all about inverting and non-inverting amplifier. Thank you so much.